This category is activated when the client says yes. The robot must find out what he is saying yes to. If the robot asks, "Do you like movies?" this category matches and the response, "What is your favorite movie?" continues the conversation along the same lines. This produces the following dialogue. Internally, the AIML interpreter stores the input pattern, that pattern, and the topic pattern along a single path, like input, that tag, that topic tag, topic. When the values of the that tag or topic tag are not specified, the program implicitly sets the value of the corresponding that or topic pattern to the wildcard asterisk. The first part of the path to match is the input. If more than one category have the same input pattern, the program may distinguish between them depending on the value of that tag. If two or more categories have the same pattern tag and that tag, the final step is to choose the reply based on the topic tag. This structure suggests a design rule: never use that tag unless you have written two categories with the same pattern tag, and never use topic tag unless you write two categories with the same pattern tag and that tag. Still, one of the most powerful applications for topic tag is to create subject-dependent pickup lines. Considering the vast size of the set of things people could say that are grammatically correct or semantically meaningful, the number of things people actually do say is surprisingly small. Steven Pinker, in his book How the Mind Works, wrote, "Say you have 10 choices for the first word to begin a sentence, 10 choices for the second word, 10 choices for the third word, and so on. A little arithmetic shows that the number of sentences of 20 words or less is about 1020.
How you can create your own chatbot. First of all, we'll see what is Elisa. You already know that Elisa is an AI program that simulates the behavior of the therapist. A program like Elisa requires knowledge of three domains. First, artificial intelligence. Second, expert system. Third, natural language processing. Even though last two are part of the first one, they are emerging as a science in themselves. Next, we see how does it work. Elisa works by matching process. Very rarely an entry sentences is matched to give the response. The rules are indexed by keywords. Some rules require no keyword. 90% of what Elisa says is found that associated data file. This file is act as a knowledge base for the complete system. The inbuilt response compare the static database of the system. Let's see how the chatbot is responds to the request. Step 1. Elisa finds out if the user has given any null input. If so, it takes the factor from the static database to respond. Step 2. There are some inbuilt responses that Elisa can recognize readily. It finds the presence of any such a sentence after fragmenting the user's input and remembers the associated keyword. This keyword defines the context of the talk. Step 3. If no inbuilt sentence framework is found, then the Elisa searches for the specific keyword to define the context. If no context is found, it is deliberately motivates the user to speak about the specific topic. Step 4. A response is chosen from the database of available responses. Step 5. Any necessary transpositions are done. For example, consider the following conversation. User says that I plan to go to Colombo tomorrow with my wife. Then Elisa responds to it by saying, and what happens if you want to go to Colombo with your wife? Here the word my has to be transposed to the your. Step 6. To simulate the human conversationalist, Elisa simulates typing and does to slow with making spelling mistakes and correcting them. What about coding? Now let us start the real coding portion. Let us first see the structure of the sample data file. .elisa recognizes certain keywords. If these keywords are found in the user input, then corresponding to that from the predefined set of response, one is chosen and displayed. This is a ELISA knowledge base. For example, in response to hello from the above dictionary, Elisa will give one of the following response. Hi, how are you? Hello dear. Once this thing is clear, let us now define the data structure that we will be using. We create two classes. Progress task. This is used to store the user's input related information. Resp. This is used to store the information about the various responses. Consider about this code. This character array user rep is used to store the lines typed by the user. Another array keyword is used to store the keywords, if any, found in that input. If a keyword is found, we make int in key found to 1, else it remains 0. As it is initialized to 0 in the constructor, key number store the key numbers of the corresponding keyword. Null lib indicate whether the user has given any null input. He is just pressing enter and doing nothing else. Now let us come to the second class, resp. The first data member .resp indicates the total number of responses for the given keyword. For example, for the hello world keyword hello, we have two responses. So for the .resp, hold the value to last resp is used to function processing and it used will be clear later on. The replies are actually stored in replies array and the corresponding keyword is stored in the array word. Description of the function in class rep. Constructors. This is used to initialize the total number of responses to 0. Why last rep is initialized to 0 will be clear when you look at the function at resp. Int getCount function. This function is also used to get the count of how many responses are there for the given keyword. Void addWord. This is used to add a keyword. Char getWord. Used to return the keyword for the particular object of the class resp. Void address resp. This is used to add a response corresponding to the given keyword. Void display resp. This is used to display the response to the user corresponding to the given index number of the responses. Actually, it does more than that. Void quit display resp. Difference between this function and above function is that it is used to the end when the user is quitting, so it does not return the prompt to the user. These are the functions that used in resp class. Let us now create the functions that read the contents of a file ELISA. An array object of the class resp, which we name keys. Since I have already explained both the format of .dat file and data structure, this function should be clear with the little or no effort. This code is commented whenever necessary. Now let us create a function for the global initialization for the transposition word. This function is easy and we will not be blibber it. Let us now write a function for displaying the response to the user. The first if statement in the flow loop is used to make a deliberate typing error to make it appear more human-like. One character is randomly